Okay, so now let's consider a situation, where we have one particular commodity, okay, and we want to define exactly what do you mean by equilibrium in a market for that particular commodity. Okay, so what do you mean by that? When do we say that we are in equilibrium? Okay, in a particular market. Okay, so there are actually two approaches to actually discussing equilibrium. One is the partial equilibrium approach. Okay, the other is a general equilibrium approach. So first of all, I'll talk about the partial equilibrium setting. Okay, so partial equilibrium approach. Okay, so why is this called partial equilibrium approach? Because the reason why we call this a partial equilibrium approach is basically we are only interested in the equilibrium in this particular market. Okay, we don't really care whether other markets are simultaneously in equilibrium or not. Is that okay? Fine. So as long as this particular market is in equilibrium, we'll call that an equilibrium. Okay, and that is why we call this a partial equilibrium approach. Obviously, this is not a very I mean, it has its own advantages and disadvantages. Advantages basically, of course, it's simplicity, because you just care about this particular market. So solving for whatever way you define equilibrium is going to be easier than actually finding an equilibrium of the entire system in the economy, where there are so many goods, so many inputs that can help you produce this particular output. Okay, I mean, basically there are so many markets at the same time. Okay, so obviously partial equilibrium is kind of a simple way of looking at equilibrium, but at the same time not a very I would say uh, not the kind of equilibrium concept that we actually find in lots of research. Okay, in economics. In fact, in most situations you will see that it's a general equilibrium model, okay, that is used. Okay, because general equilibrium model actually in a certain way is kind of you know a better way of approaching things, but at the same time a little bit more complicated as well, because looking at trying to figure out the prices at which all markets clear simultaneously is not a very easy problem to solve. Okay, so obviously both has its advantages and disadvantages. Okay, uh, uh, so uh, the kind of results that we actually prove in the kind of things that you will see later on in books will involve general equilibrium models. Okay, in fact everywhere you'll see general equilibrium models in trade, in macroeconomics it's full of general equilibrium models, dynamic general equilibrium models. In micro also, of course there are lots of general equilibrium models involving production. We have general equilibrium models with public goods. We have general equilibrium models with externalities. We have general equilibrium models where we have intertemporal choice kind of problems. Okay, we also have general equilibrium models where there is some sort of portfolio selection or asset pricing. Okay, so I mean you will find them everywhere. Okay, in economics. Okay, so but let's first discuss the partial equilibrium approach. Okay, and what we're going to do is we'll assume that firms are competitive. Okay, what that means is firms are price takers. Okay, and let's say there is only one good. I mean, of course there can be more goods, but let's consider one good. Okay, just this particular good, let's consider just this particular good, and there are many uh, basically n suppliers of this particular good. Okay, so all those firms are basically have their own technology which they can use to actually produce this particular good and supply it in the market. Okay, and let's assume that there is some demand curve, which explains the demand behavior in this market. So of course, there is a possibility that you may be given consumers whose utility function is given, and from those utility function you have to figure out the demands. Okay, but in this model right now, what I'll do is I'll keep it simple. I'll give you the demand function. Okay, so as I mean, you already know how to find the demands. So even if the utility functions are given, you can find the demands. But let's keep the model simple for the time being. Let's say the demand is given and there are n firms in the industry. Okay, each of those firms have some production function, or basically some access to some technology. Okay, and they are the potential suppliers of this particular good. Now we want to define an equilibrium or competitive equilibrium, in this particular setting. Is that okay? Fine. Okay. So this is how you define competitive equilibrium. Okay. By the way, this is also known as short-run competitive equilibrium. The reason why I'm saying it's short-run because we don't allow firms the flexibility to move out of the industry, and we don't allow firms, which are outside the industry, the flexibility to enter the industry. Okay, so again, there is some kind of lack of flexibility, because that's what I told you, right? I mean, short run is kind of a period where there is a reduced flexibility available with the players. Okay, fine. Okay, so let me define short run competitive equilibrium. Okay. Okay, and let me also just quickly tell you the setting, okay, that we are in. What do we have? Okay, so we have n firms. Okay, each of those firms has some technology, and you know that we can always take the production function and convert it into the cost function. Yes or no? Okay, we know how to convert production function into cost function. Yes or no? Just solve the cost minimization problem and you'll get the cost function. Okay, so each of those firms have their own cost functions. Okay, so firm 1 has cost function C1, firm 2 has cost function C2, firm 3 has cost function C3, and so on and so forth. So basically firm I has cost function Ci. Okay, so that's the cost function of the ith firm. Okay, of course cost function is a function from r plus to r plus, which is of course increasing, because the higher the amount of output you produce, the higher will be the cost of producing it. Okay, so Ci is the cost function, okay, of firm I. Okay, and there are n such firms. Okay, and let's say the demand is given by some function, which is, let's say, let me write the inverse demand function. Okay, so the inverse demand function is PDQ. Okay, so this is the demand function. Okay, fine. So this is the data which is given to you, and for this particular environment we want to define competitive equilibrium. Okay, so this is how we define competitive equilibrium. Competitive equilibrium consists of prices. Okay, so, well, in this case there's just one product, so the price, okay, price of X, okay, P star, and how much does each firm produce, okay, at this price. So Q1 star, Q2 star, and Qn star. Okay, so this price quantity, combinations is a short run competitive equilibrium if the following holds. First, each of those price taking firms should be maximizing their profit you know, by choosing, you know, this quantity qi star. So each firm I chooses quantity qi and maximizes its profit at qi star, taking price p star as given. Okay, so basically qi star solves firm I's profit maximization problem, which is maximized with respect to qi p star qi minus ci qi. Okay, of course qi has to be non-negative. Okay, so basically qi star is a solution to this problem. Okay, and this is true for all I. Okay, so this is the first requirement. Okay, for equilibrium. The second requirement is that the total supply must be equal to the total demand. Is that okay? Fine. So if qi star is the supply of ith firm, then what is the total supply of all the n firms? Right? Okay. So this is the total supply of all the n firms at what price?
P star.
P star. Okay, so obviously P star and summation qi star is a point on the supply curve. Yes or no? It's a point on the aggregate supply curve. Yes or no? Because
Yes, sir.
at price P star, this is the total supply. Now for equilibrium, what must be the case? For equilibrium, this point P star, comma summation qi star must also be on the demand curve. Okay, so what do you mean by that? This is the demand curve. Okay, it means that if you put this in the inverse demand function, you should get P star. That's it. Have you understood this? Okay, so this is it. That's the definition of short-run competitive equilibrium. Each firm maximizes profit at price P star, okay, by choosing qi star, and the total supply decision must at price P star must be such that this pair must also lie on the demand curve. Have you all understood this? Okay, so now we can solve for short-run competitive equilibrium. So what I'll do is I'll give you you know, some data. Okay, I'll give you the demand function. Okay, I'll give you cost functions, and you have to figure out the short-run competitive equilibrium. Okay, fine. Okay, let's do it. So suppose there are two firms. Okay, two firms. Of course, we are assuming firms are competitive. I mean, it's not a duopoly model. Okay, it's a competitive firm situation. Okay, so suppose there are two firms. Okay, and the cost function of firm 1 is C1Q1 is equal to 4Q1. Okay, and cost function of firm 2 is C2Q2 is equal to Q2 squared by 2. Is that fine? Okay, now suppose the demand curve is this. So P dq is equal to max of 16 minus q comma 0. Okay, so take 5 minutes and find the short-run competitive equilibrium, because that's all you need, right? I mean, you need the data on the cost function and you need the data on the demand curve to find the short-run competitive equilibrium. So you have all the data with you. Find the short-run competitive equilibrium. Okay, so let me give you the hint. So this is how you can approach it. So first find the individual supply functions of the two firms. You know how to do that, right? We have already done that. So you know how to find the supply function of firm 1, you know how to find the supply function of firm 2. Then using the two supply functions, find the aggregate supply function of this particular commodity. Once you have the aggregate supply function, you already have the aggregate demand. So you just need to solve for the equilibrium price and quantity by equating aggregate demand and supply. Okay, now do it. Okay, so I'll just, I'll not find the supply and everything. You know how to find the supplies. You have done so many problems now. I mean, these are really easy compared to the ones that you have done so far. I'll just quickly do this, just by looking at the problem, So if you see price greater than 4 is definitely ruled out, because if price is greater than 4, then firm 1 would want to supply infinite amount of output and the demand is finite. Okay, so price greater than 4 is not possible. Is that okay? So price is either 4 or less than 4. Okay, you can also check that price less than 4 is not possible, because if price is less than 4, okay, if you look at firm 2, firm 2 supply function is basically Q2 equal to P, right? Q2 equal to P, because if you take the derivative, you'll get Q2 equal to P. Yes or no? So firm 2 would want to supply exactly equal to the price. So if price is 3, the firm 2 would want to supply 3. If price is 4, firm 2 would want to supply 4, and so on and so forth. Okay, so if price is less than 4, firm 2 would want to supply less than 4. Okay, but the demand when price is less than 4 is about 12, is greater than 12, right? Because if price is less than 4, the quantity, if you just solve this, the quantity demanded will be more than 12. Yes or no? Okay, so if price is less than 4, quantity demanded is more than 12. If price is less than 4, the quantity supplied is less than 4, so obviously market will not clear. Okay, so the only possibility is for equilibrium is price equal to 4. Now if price is equal to 4, then firm 2 would want to supply 4 units. Okay, because firm 2 would want to supply Q2 equal to P. So as long as price is P, firm 2 would supply P units. So what that means is if P is 4, firm 2 would want to supply 4 units. Okay, but what is the total demand at price equal to 4? At price equal to 4, the total demand is 16 minus 4, which is 12. Okay, so if the total demand is 12, then what is the remaining demand? Actually 8. Okay, so yeah, so 8 units will be supplied by firm 1. So it's not 7, it's 8. Okay, so so this is the equilibrium. Q1 star is 8, Q2 star is 4, and price P star is also 4. Okay, so this is basically your competitive equilibrium, and firm 1 can actually supply any amount. When price is 4, it can supply any amount. So we have just told firm 1 that okay, you supply 8 units, because firm 1, no matter what it does, it makes 0 profit. So 8 is also profit maximizing for firm 1. Is that okay? Of course, another way to do this is find the supply of firm 1, find the supply function of firm 2, aggregate them, find the aggregate supply, plot the demand curve, plot the supply curve, look at the intersection and find it. Okay, that's another way of doing it. I hope you can do that way. It's not difficult, it's very easy. uh, just elementary stuff. So just make sure you write the supply functions properly. When you are aggregating them, just be careful, and then there'll not be any problem. You'll get exactly this equilibrium. Okay,